Hi everyone, welcome to Lecture 4 Part 2 on inductive and deductive arguments. The objectives for this video are the following things. So after watching, everybody should be able to: Number 1, define what it means for an argument to be deductively valid and inductively strong. Number 2, define the inductive probability of an argument and describe how it is determined. And number 3, evaluate the inductive strength of an argument. Now, remember, we finished last time by saying that arguments have varying degrees of strength. We said that when the truth of the premises of an argument guarantees the truth of its conclusion, we have the strongest possible type of argument, and that there are cases ranging from this maximum possible strength all the way down to the lowest possible strength, where the premises contradict the conclusion. In this video, we're going to make this idea of the strength of an argument more precise. So here are the first two definitions towards that goal. The first one will be a recap from the validity lecture. So here it is. Definition 1 says that an argument is deductively valid just in case it is impossible that its conclusion is false and its premises are true. Notice we've written this slightly differently to how we did before. We've introduced this term impossible. Now I'll say a little more about that in just a second. We're stating it this way here for comparison. So remember, a deductively valid argument is the strongest type of argument that we're concerned with in this class. So what do we make of arguments that aren't deductively valid? Now, we say that an argument is inductively strong just in case it is improbable that its conclusion is false, given that its premises are true, and that it's not deductively valid. We say further that the degree of inductive strength of the argument depends on how improbable it is that the conclusion is false, given that the premises are true. Now, there are two crucial terms in these definitions that it's worth spending some more time talking about. The book talks about this too, but the corresponding terms used in the definitions are slightly different there. I'm not really sure why it's like that, so use the ones that I've given here if they come up in an exam. Now, the first of these terms appears in definition 1 of deductive validity. The term we're interested there is impossible. So what do we mean for something to be impossible here? Now, there are two ways of understanding impossibility here, and while one of those ways is important for us, the other is not. So here's an argument as an example. It says, my grandma is 86, my grandma has a cane, therefore my grandma will not run a marathon tomorrow. Now here the conclusion is physically impossible. It's physically impossible for my grandma to run a marathon tomorrow. She's not going to do it. But it is not physical impossibility that we mean by impossible or impossibility. What we mean by impossibility is logical impossibility. And actually, the conclusion of this argument, as it's written here, is still logically possible. Now, to get a sense of the difference, observe that this argument is not deductively valid. For this argument to be deductively valid, we would need a premise asserting that no 86-year-old grandma with a cane can run a marathon tomorrow. Of course, we all believe that's true, but there's nothing down there in the premises that claims this to be a fact. Now, if we added that premise, then we would have a deductively valid argument, but as it's written here, it's not deductively valid. So the crucial point is this. If an argument is deductively valid, its conclusion makes no factual claim that is not, at least implicitly, already made by its premises. Therefore, it's logically impossible for the conclusion of a deductively valid argument to be false and its premises true, because if the conclusion is false, then it must contradict some of the factual claims made by the premises. And it's this version of impossibility, logical impossibility, that we mean in the definition. Now, on the other hand, the conclusion of an inductively strong argument ventures beyond the factual claims made by the premises. So, we might be able to describe situations in which the premises would be true and the conclusion false. That's why the conclusion of the grandma argument is still logically possible. Now, definition 2 from before stated that an argument is inductively strong just in case it meets two conditions. One, it's improbable that its conclusion is false given that its premises are true, and two, it's not deductively valid. The second crucial thing I want to talk about is the term given that in condition 1 here. The point is that the phrase given that cannot be replaced by and here, although it might look like those terms can be interchanged. So what's the difference? Here's an argument. This is an example from the book. It says, there is a 2,000-year-old man in Cleveland, therefore there is a 2,000-year-old man in Cleveland who has 3 heads. Now, this argument is not deductively valid, so it meets condition 2 on the screen there. Let's look at how we evaluate this argument according to condition 1, which said an argument is inductively strong just in case it's improbable that its conclusion is false, given that its premises are true. Well, given that the premise of this argument is true, it's still probable that the conclusion is false. Because if we suppose there's a 2,000-year-old man in Cleveland, then he probably only has 1 head. So by condition 1, this argument is not inductively strong, because it's probable that the conclusion is false, given that the premise is true. Now let's suppose condition 1 reads this instead, condition 1 star. That says it's improbable that its conclusion is false and its premises are true. So we've swapped given that for and here. Now, for the premises of this argument to be true and the conclusion to be false, there would have to be a 2,000-year-old man in Cleveland, and that's certainly improbable. So it's improbable that the premise of the argument is true and the conclusion is false, simply because it's improbable that the premise is true. But then by this new definition, condition 1 star up here, this argument would be inductively strong, which it certainly isn't. So the point is this. Definition 2 is the correct definition of an inductively strong argument. You cannot replace the phrase given that with the word and. And just one more word before we move on. If you're wondering why we need condition 2 at all, then you'll have to keep wondering because that's an assignment question. So we've seen that by impossibility we mean logical, not physical impossibility. And we've seen that we really do mean given that in the definition of an inductively strong argument and not the word and. Now our discussion of the last thing illustrates an important definition / principle. Inductive probability is the type of probability that grades the inductive strength of arguments. And inductive probability does not depend on the premises or on the conclusion alone, but on the evidential relation between the premises and the conclusion of an argument. Now all that means is what we've been saying. So when you evaluate inductive arguments, it doesn't matter to the strength of the argument whether the conclusion alone is probable or whether the premises on their own are probable. The only thing that determines the inductive strength of an argument is how probable the conclusion is given that the premises are true. And there'll be some exercises that tests your knowledge of that principle in the problems this week. Now here's one last example to finish off this video. We're going to evaluate the inductive strength of this argument. It says, there is a man in Cleveland who is 1,999 years and 11 months old and in good health. Therefore, no man will live to be 2,000 years old. Now, I'll tell you for free that this argument is not deductively valid. Let's pause for a question because I also want to reinforce the principle that we've just been talking about. that the inductive strength does not depend on the probability of the conclusion or the premises considered on their own. So have a go at this question. Okay, so the conclusion of this argument is highly probable. I'm sure we all hopefully agreed. Now here's the next question. Okay, so if the premise were true, that is, given the premise, the conclusion would probably be false. That is, that guy in the argument probably would live to 2000. So some man would live to be 2000 years old. So here's one last question. Okay, so while the conclusion considered on its own is probable, the conclusion given the premise is not. Again, the inductive strength of an argument does not depend on the probability of the premises or the conclusion considered on their own. It's to do with the evidential relation between premises and conclusion. So after all of that, by our definition, it is probable that the conclusion is false given the premise, so this argument is not inductively strong. So what have we learned here? We began this lecture by saying that arguments have varying degrees of strength, and now we've seen this, that deductively valid arguments are the strongest type, followed by arguments of descending strength all the way down to the kind of worthless arguments at the bottom of the strength scale. And we've also seen the following important thing. Deductive arguments are either valid or they're not, they're invalid. Inductive arguments, on the other hand, are either strong or weak. Inductive arguments cannot be described as valid or invalid because the definition of validity only makes sense for deductive arguments. Now, we typically think of deductively valid and inductively strong arguments as the good ones, and deductively invalid arguments and inductively weak arguments as the bad ones. Now, we've also been using the term inductive probability a lot. So in the next lecture, we'll contrast that type of probability with another one called epistemic probability. So I'll leave off here and I'll see you next time. Have a go at the last question just before we finish.